So today we are going to be solving a nice trigonometric question that was present in my school math exam. The math exam was on the topics trigonometry, linear inequalities, permutation combination and the conic section. Overall the exam was very nice and good. Most of the questions were from the chapter conic section and they were very easy. But from the whole question paper, I personally liked the question number 21 that was to prove this particular trigonometric equation, and by doing so you can easily get 5 marks. Okay. So after the test, I thought to share this equation with you all. So yes, the video. So the question is very simple. We need to prove that the left hand side has a value 1 upon 16. So to prove this thing, let us start from the left hand side. So in this equation, the left hand side is simply cos 20 degrees multiplied by cos of 40 degrees multiplied by cos of 60 degree multiplied by cos of 80 degrees. Now we need to show that the value of this thing is 1 upon 16. So we have 4 terms over here that are in multiplication. So the first thing we can notice over here is cos of 60 degree, that has a direct value 1 upon 2. So I can plug in that value over here. So 1 upon 2 multiplied with rest of the thing as it is, that is cos of 20 degrees into cos of 40 degrees into cos of 80 degrees. Okay. Now to solve this thing further, we need to use a trigonometric identity, that is 2 times cos of A into cos of B is equals to cos of A plus B added with cos of A minus B. So this is the identity that we are going to use. So here we have these 3 terms in multiplication, means these 3 cos values in multiplication. So out of this, first of all I will take cos 40 into cos 80. Now there is one thing to be noted over here. The identity says 2 times the product of cos A cos B equals to this thing. But what if only cos A and cos B is present? So simply we need to divide this identity by 2 on both of this side. So we will simply get the value of cos A into cos B equals to cos of A plus B plus cos of A minus B divided by 2. So now let us apply this identity. So 1 upon 2 as it is first of all, multiplied with cos of 20 degree as it is, multiplied with, now taking this both as multiplication and applying this identity will give me cos of 80 plus 40, that is 120 degrees, plus cos of 80 minus 40, that is going to be 40 degrees, and divided by 2. Okay. Now what I will do is I will simply take this 2 outside because this and this bracket are in multiplication. So 1 upon 2 into 1 upon 2 will become 1 upon 4. And also I will open this cos of 20 degree with these 2 terms. So cos 20 multiplied with cos 40. So cos of 20 degrees into cos of 40 degrees. And now look carefully. Plus cos of 20 degrees into cos of 120 degree. So recall the identity that cos of theta is present, and value of cos of 180 minus theta would simply be negative cos of theta. Not this thing is required. Cos of 180 minus theta is simply negative cos theta. So in this I will replace theta as 60 degrees. So I can see cos of 120 degree would be equals to negative cos 60. So over here cos of 120 degree can be replaced as negative cos 60. So this plus will become negative and cos of 60 degree in multiplication. Okay. Now we need to simplify this thing further. Okay, so we have reached this particular equation. Now what I will do is I will apply the same identity in this particular pair and in this particular pair. So what I will get is 1 upon 4 as it is outside the bracket first of all, multiplied with. Now applying the above discussed identity over here, I will get cos of 20 plus 40, that is 60, plus cos of 40 minus 20, that is 20 degrees, divided by 2, minus over here cos 20 into cos 60 will give me cos of 60 plus 20, that is going to be 80, plus cos of 60 minus 20, that is going to be 40, divided by 2. Okay. Now I can again see that 2 is a common denominator in this both terms, so I can take that thing common and multiply with 1 upon 4. So what I will get outside the bracket is 1 upon 8 multiplied with cos of 60 degree plus cos of 20 degrees minus cos of 80 degrees minus cos of 40 degree. Okay. This negative sign open with this and this, both of them become negatives. Okay. Now what I will do is I will again use a trigonometric identity, that is cos of A plus cos of B is equals to 2 times cos of A plus B divided by 2 multiplied with cos of A minus B divided by 2. Now again we can see that we have to take 2 pairs of cos A and cos B. Now we cannot take this particular pair because if we apply this particular identity in these 2 terms, we will again reach back to this term. So the other pair that I will take is this both. So what I can see over here is cos A minus cos B. So this identity will not work over here. So no need to worry, there is an identity for this one also. So cos of A minus cos of B is simply negative 2 times sine of A plus B divided by 2 multiplied with sine of A minus B divided by 2. So we can simply apply this identity to that both terms. So first of all, 1 upon 8 outside the bracket as it is multiplied with. Now look carefully, we have cos of 60 degrees. So this can be just replaced as 1 upon 2, its value. Now this negative cos 40 at the end as it is. Now the main thing, that is applying this identity to these both terms. So negative 2 times sine of A plus B upon 2, that is 80 plus 20 upon 2, that is going to be 50, multiplied with sine of 20 minus 80, that is negative 60 divided by 2, that is negative 30. And we know this particular thing, that sine of negative theta is negative sine theta. So that negative will come in front of this particular whole term because it is in multiplication, and that will make this negative as a positive sign. And this thing will simply turn out to be sine of 30 degree. Now we know the value of sine of 30 degree, that is going to be 1 upon 2. So first of all, let us rewrite this equation, 1 upon 8 as it is multiplied with 1 upon 2 minus. Now what I will do is I will just change this cos of 40 in terms of sine, because we can see the rest of the term is in terms of sine. So we know this complementary rule that sine of theta is equals to cos of 90 minus theta. It's very simple. Draw a right angle triangle. Here is 90 degree, here is the angle theta. Therefore by angle sum property, this angle would be 90 minus theta. Let the sides be A and B and the hypotenuse be C. So in this right angle triangle, the value of sine of theta is going to be A upon C, opposite upon the hypotenuse. And in the same right angle triangle, the value of cos of 90 minus theta, that is one of this angle, would be equals to adjacent upon the hypotenuse, that is again going to be A upon C. So we can say that by comparing this equation, we can say sine 90 equals to cos of 90 minus theta. This is the rule that we call as the complementary angle. So we can simply apply this rule over here. So what I will do is I will replace theta as 50 degree, because we need to convert cos of 40 degree in terms of sine, and over here by replacing theta as 50, we can get cos 40, and on the other side we will get sine 50. So cos 40 can be replaced as sine 50, so sine 50 over there. Now rest of the things as it is, so let me remove this thing from here. So plus 2 times sine of 50 into sine of 30 degree. Now recall the value of sine 30 degree, that is going to be 1 upon 2. So this 2 and this 2 can be cancelled out. So what simply remains over here is sine of 50 degree, bracket close. Now negative sine 50 and positive sine 50 can be cancelled out. So what finally remains is 1 upon 8 multiplied with 1 upon 2, and this thing is going to be 1 upon 16. And recall that we were simplifying LHS, that is the left hand side, and we have got its value as 1 upon 16, and that is equals to the right hand side that we need to prove. Hence we have proved this particular equation. So this was my way to prove this trigonometric equation. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.